You may not know who the heck we are. I'm Colin Maynard, ESE. Was raised in Anchorage, went to college in Boston, and then worked in New York for about 3 years, doing everything from plywood box beam, hot dog counters to 43-story coffee glass towers. Moved back here in '83, worked for a couple of years, went out to Colorado, got my master's, to get back here in '87, and worked until I retired at the end of 2021.
Dennis Berry, Anchorage, my hometown, went outside to college, came back, been here since. I guess that would have to be spring of '76, practicing structural engineering. Currently president of BBFM Engineers, which is where Colin retired from. And outside my college was a master's and a bachelor's from Stanford University.
Dive in?
Sure. Yeah, we're two survivors. Yeah, we're still here. Good Friday earthquake, March 27th, 1964, 5:36 p.m. 9.2 seismic moment magnitude. Big. There were actually no strong motion instruments in Alaska at the time of the earthquake. So best estimates on ground shaking in Anchorage are about 0.2, about 0.2 Gs. Ground shaking, at least 4 minutes. Some people will say it was 5 or 6.
Yeah. The official one says 4.5, 4:38 or something like that. A long, long time.
A long time. Numerous buildings damaged, collapsed. A lot of that had to do with the ground failure that did occur in Anchorage. Across the state, 107 bridges collapsed. There were 112 deaths in Alaska, 8 in Anchorage, 12 in California, and 4 in Oregon. Now, the crazy ones were the guys in Crescent City, California, that went down to the beach to watch the tsunami come in. And they did not run fast.
Crescent City's been hit by tsunamis at least 3 times since then, so it's not a place I would move to. Most of the deaths were from the tsunami, not from the earthquake motion. Valdez, Seward, Kodiak, Chigney, and Prince William Sound. Yeah, that was practically wiped out. And we're going to tell you where we were when this happened. We were living, is it? Oh, yes, that's right. There you go. Why don't you start?
Actually, my whole family was in the 4th Avenue Theater. The Sword and the Stone, the classic Disney cartoon feature, had literally just begun when the earthquake hit. I did not actually see that until probably about 10 years ago in its entirety. 4th Avenue Theater, not here anymore, is it? And I'll just add one other quirk to it. My mom was the head usherette when the 4th Avenue Theater opened.
And we were living in that duplex, which is no longer a duplex. I think it's an office building. I think its current address is on 69th, though I think you still have to access the off of Seward Highway, or Old Seward Highway, which was the Seward Highway back then. We're on SRA, Star Route A, out in the middle of nowhere. We told people we're at mile 3 of the Seward Highway. That's how people found us. I was watching Fireball X05. It had just started. It is a old claymation space kind of thing. And the rocket had just started launching off when the earthquake started. And
So how old were you?
I had just turned 7, 10 days before that, or 9 days.
7.
Yeah.
And Dennis?
A second, I think I was 11. I was in the 6th grade. A little quirk in the 6th grade. So we got out of school for 2 weeks. My 6th grade teacher sent homework out to us in the community, so we had stuff to do when we came back to school in 2 weeks.
Yeah, I was in 1st grade at Northwood. We had just moved into the building because we had double shifted the first semester because Northwood wasn't done. I had spent kindergarten the first weeks of that previous summer at Abbott Loop, so that I would be used to being away from mom and get used to the building. Then they changed the boundaries and went to Northwood. Anyway, so mom was in the kitchen cooking sweet and sour pork. We had been out mushing dogs around the lake at the end of the airport. It's now a dog park. My mom did not do either after this date. She dragged my sister out of the kitchen and into the living room where I was. I was bouncing around on the couch with this huge plate glass window behind me. And all I did was say, what happened to the TV? Because it had gone out. All the power had gone out. And we waited for Dad to get home. Then we went downtown to try to get a friend who lived at 9th and N out of the tidal wave zone. But there was National Guard was already out there. They wouldn't let us go in there. Came home. There was a station wagon parked in our driveway. The family that was turning in were waiting out the tsunami alert, and we had them come in. That was Friday night, and they didn't leave till Tuesday. It was a big earthquake. Yeah, it was a big earthquake. It's the blue circle is the subsidence area. The other one is the uplift. Places moved vertically up to 30 feet. The area around Portage that is now all water was above ground. It was actually a small community there. I'm not sure you can see any of the buildings anymore, but you did for decades afterwards as the wood buildings failed. That largest ever recorded on North American continent.
Well, everybody's kind of, I mean, ground failure was the bootlegger cove clay formation caused most of the damage, and that was the 4th Avenue slide, the L Street slide, and of course the Turnagain slide. Each one a little bit different in terms of what they did. There were additional slides at Government Hill Elementary School, which had a major impact on that school, and Alaska Native Medical Center, which led to them finally, building the new Native Medical Center at the new site away from the ground failure.
Yeah, 30 years later.
Yeah, yeah. So 4th Avenue, I mean, it's all pretty clear in terms of where it all happened. Major, intermediate ground subsidence, major ground subsidence.
The Graben.
The Graben, where this block moved and the Graben was created, which is where you see most of the buildings. I mean, that's where the buildings dropped into the Graben when the block moved.
Yeah, infamous picture of the Denali Theater.
Yeah. Yeah, we've got that one.
Yeah.
When we came out of the 4th Avenue Theater, my whole family, in other words, my sister was up in the balcony, and I can remember turning around and watching it here. Yeah. And seeing it move. The 4th Avenue actually came through pretty well. First major concrete building, and I think in Anchorage was the 4th Avenue Theater. Didn't look down the road this way. If I would have seen what was going on. I mean, we just kind of gathered up, went over, picked up my grandmother who was living on 6th Avenue, just about a half a block from the L Street Graben. Didn't see that either. My grandmother came and stayed with us at our house. And, our homes, her home even was fine too. The only thing about her house is the house is actually still there on 6th Avenue. The kitchen cabinets opened up and literally the floor was covered with broken dishes in the kitchen.
Yeah, we had a whole bunch of molasses and other stuff on our floor. It was a mess. Yeah. My dad was an architect, Ken Maynard, some of you may have heard of him. He had just designed, and they had just opened the NBA Bank here at the corner of 4th and E. And it was designed by, the structural engineer was Art Jacobs. So it was right across the street from all of that mess, and all it had was a crack in the slab on grade in the basement. He ran into a executive from NBA at Cars about a week or two later, and Dad had not been there, and asked him how it went. He said, "Oh, you didn't hear it collapsed." What? No, it's fine. My dad did not think that was funny. The building that was the Hard Rock Cafe at one point and is now something else. I don't remember. The safe is still down in the basement though. But speaking of my dad, when he was working for Ed Crittenden at the time, and their office was over here at 9th and I. He got to work on Monday morning at 8 o'clock, and Ed said, "Don't take your coat off. We're going out to City Hall." And basically, the entire design community was working out of City Hall. Dad was sending teams off to the buildings that had not been inspected, and then collecting the reports. And they spent, I think, about a week inventorying all the buildings and giving them basically red, yellow, and green cards long before people knew about red, yellow, and green cards. And there were a number of building owners that would get a red card and they would say, no, this is fine, we just need to do this. And then they heard that they're gonna be, 1% loans from the federal government for repairs, like, oh yeah, no, it's a red dot.
The pictures that we're showing are actually slides that my dad took after the quake. He was an electrical engineer with FAA, and so all I did was scan these things in, and you can kind of see, there's looking down Fourth Avenue, there's the graben where things dropped in. Westford Hotel Tower was actually just finishing construction, that old tower, and
Yeah, it's a construction elevator up.
yeah, still there, yeah. And here's the iconic picture of the Denali Theater with the marquee level with Fourth Avenue after it dropped in the graben. You probably, there's any number of those pictures wandering around. So, I mean, basically the ground moved, created a void, buildings dropped into it. That's what happened.
And I did this presentation for a Rotary Club in that room up there a few years back. And one of the people in the meeting said, yeah, I knew a guy who was in that space during the earthquake. And he said he could see the ground, he could see the sky, he could see the ground, he could see the sky. And a lot of people have talked about, telephone poles or trees that were hitting the ground on one side and going back to the other. There was fairly big waves as it came through. There's the Denali Theater.
Yeah, close up on the Denali Theater. I mean, some of this is, you can see they're actually getting down in here, trying to clear some stuff out already when my dad took these pictures. Of course, that's they're calling that these days.
The McKay building.
It was the McKay building. I don't know what.
Oh, yeah, it was McKinley. It was the McKinley Towers. Then it was McKay building. Now it's back to McKinley.
We've got some closer pictures on that further on.
Yeah, the Denali Theater moved to Spenard and is now the Beartooth.
Just more pictures and stuff that kind of fell in the ground, and you can see part of it still up on the road. That one dropped back down into the hole. Pieces falling apart on buildings. Some of these get a little bit more interesting. As you can see, there's not a lot of structure around the front of that one. This is down by the railroad. That's the railroad terminal building. It's still, the one that's still down there. Yes. And
Yeah, not much of a lateral system in front of that building
no.
or that one.
I think some of these you could say it's not a soft first floor, it's like a soft everything. L Street. Of course, we've got 9th Avenue here, is 5th Avenue. The graben came through here and went right through there. Some of you might realize that, let's see, where's 5th Avenue? So that's right where the parking garage is right now, sitting on the old graben spot. A lot of this is still kind of, well, you're kind of mimicking.
I'm following you.
Yeah. But it kind of came through here, swung by. This is, yeah, that's
That's the old Providence.
the old Providence Hospital.
Yeah, which is where Benihana's is now.
Yep. Yeah, that was a,
And the hotel.
and literally this whole block just went that way. The graben created out here. All the buildings on this block are still looking fine. Anything this side of the graben was pretty much okay too. But there's a lot of stuff that fell in the graben.
Yeah, pretty much that whole block moved 15 feet west. So when they went back and looked at it, the buildings were in rights of way, the water and sewer lines were in people's property. So they went and resurveyed everything 15 feet west, and L Street gained 15 feet.
Yeah.
For a long time until it got widened, you could stand at 5th Avenue, look down L Street and you could see the jog.
The offset that occurred.
And there used to be tennis courts right about there where that little kind of circle is. But now it's got a little drop in it, so it's really hard to do that.
And this is not the first time this has happened. This event, this earthquake of this magnitude has happened before. It will happen again. These land movements have occurred before. They will happen again. That's looking up Sixth Avenue. This building is now currently gone. This is the ground. My grandmother's house is literally half a block on that side of Sixth Avenue. The stuff that fell in, or they've filled the roads and they keep going. This one, on like Seventh and L is where this thing was located. This piece they actually picked up and moved down Ninth Avenue, and that piece is still there in place. They didn't. Now, some of this is kind of, your classic stuff that fell off. You don't want to be going out the front door of this building at the time. That would have been bad news. But then you look at some of this stuff and I find this fascinating, how that thing is literally cantilevering out over the void. It doesn't look all that bad considering.
Yeah, where it wasn't really attached well to the foundation.
Well, there is that too.
Actually, the building that's at the corner of Sixth and L, Nick Arms, it moved 15 foot west and it's still there. And it was basically intact. It just went with the soil. Had no real damage to it.
Yeah, you can see where it, right there, there's the edge of the ground right there going through that building. This house is still doing. I mean, it's like the windows didn't break on it. So that was, and that's before plywood. We're talking probably board sheathing on that. Looking down the alleyways where the graben was going, temporary water lines and everything that went in. Of course, that's inlet towers.
Yeah.
Down at the end of the distance.
Yeah. Yeah, Inlet Towers and the McKay building are basically the same design and had the same kind of problems.
Yeah.
Yeah, there's the building that mid 15 foot west and
Concrete.
it's concrete, it's still there.
Yeah. Robin's about a half block up this one.
And turning the slide.
Yeah, Turnigan wasn't quite as neat. It started moving, then it kept moving and it moved up enough that it just literally broke up. So anything that was out in the Turnigan slide area, we've got some pictures showing some of the houses. There were 2 to 3 people that were in that slide and they never found them.
And including 2 children.
Yeah. No, I mean, seriously broke up. I mean, it's not like it just slid and there was a creek. It just, the whole thing as a block moved and then the block just started breaking up, which was what you can see from the picture.
Yeah, when they created Earthquake Park, it was obvious that there'd been an earthquake and it's tossed and turned. Now it's got so many trees that have been there for 60 years that it's hard to tell. But if you go walk into that, forest, you will see that the land is not exactly a uniform slope.
And a lot of people are in the area that moved. I mean, what they did back there was they gave them property elsewhere in Anchorage. The only thing is they didn't take the property they had here. So some of those homes you see along the coastal trail are property that was still in private ownership that has been redeveloped. Definitely in the old Dell Street, the Turnigan slide area. Roadway's a little bit messed up.
Yeah, portion isn't doing too well, but the rest of it's not too bad for leaning at about 15 degrees.
Yeah.
But just a whole lot of windows in it.
No, but just that these blocks were just going everywhere once they started breaking up. In some homes, they pulled out and put someplace else. I'm sure that house is still right there. It's just, less than a block away. That house would come.
Be another one there,
Yeah. There's a lot of other damage outside of the slide areas. This one, what's interesting about it is you see that, you see that whole crack right through there? That's this floor on the, that's the street side on the other side of the building.
16th Avenue.
Yeah.
Would have been just east of I Street, I think.
Yeah.
That's between G and H, so yeah, just east of I Street.
Not a lot of shear capacity in the exterior walls of the building. Basically, that building was torn down afterwards. It was not salvageable.
Yeah, you don't see a whole lot of rebar in CMU either.
Mm.
That was one thing that they found in a lot of CMU buildings that they tore apart. I like to say the masons were crooks. You saw one of 2 things. The block had grout in it, but there was a hole where the rebar had been inspected. And then as soon as the inspector left, they pulled the bar for the next course, and the grout held its form because it had been setting for a while. The other one was with rebar that was there, but there was no grout because they would put a liner at the bottom of the bond beam and fill up the bond beam, so it looked like it had been grouted, but there was nothing below it between the bond beams.
Well, I mean, basically that's telling you a lot of the old masonry buildings in town, there's some that really have significant problems with them because of the quality of the construction. Special inspection was the best thing that ever happened to masonry in this town. The old control tower pancaked, and there was one person in that when it came down that didn't make it out. And incomplete lateral load system, I mean, just read the notes, you know, probably wasn't really designed for earthquake, you know. The old C concourse, before they finally replaced it, there were like half a dozen studies saying, this thing really shouldn't still be here. This is long before they replaced it, but
But it went through the 64 quake.
yeah.
Has anybody heard that before? Yeah. We don't know how.
Yeah.
And this is the Alaska Sales and Service. It was under construction. It's precast elements. Those columns with the arms, they're, you know, the T's, and then single T's spanning over that. And basically they kept the ones that fell down that were still good and threw away the ones that weren't good, and then built it. And it's still there now. I actually looked at this building after the 2018 earthquake, and it was basically fine. They had done a seismic upgrade about 2 or 3 years before that. There were some cracks, and you know, some of the connections between columns and the walls had popped, at least popped the grout cover on it, but the connection seemed to be still there. So it definitely moved. Yeah, so some of these were not salvageable and some were, and they lifted them back up into place. And if you don't know that they actually have a parking lot on top of that, so they keep cars on top of that building. This is J.C. Penney building,
The old J.C. Penney.
yeah, which is in the same location as the current J.C. Penney building, but obviously it's not 5 stories anymore. And it doesn't have precast concrete panels on the outside. It also had a very large eccentricity because it had 2 very long walls on 2 sides, and on the other 2 sides, there were 2 short walls on the opposite corner. And so the center of rigidity was way off of where the center of the mass was. And the precast panels tried to start to take some of the load, but the connections obviously weren't designed for it. And they didn't go all the way to the ground. And so they started shedding those. We had a friend who was on the 2nd floor of this building when the earthquake started. And when it kept going, she said, I'm out of here. And this lady that was standing next to her said, I'm going with you. They ran down the escalator and out the front door. She was on the sidewalk. She was going to get away from the building. There was a crack opened between 2 cars and then closed up again. She ran between the 2 cars. And then she found herself in the back of a station wagon going east on 5th. It was 2 ways at that point. She has no idea how she got in there. She must have jumped in because the glass was down on it and she was getting out of there. The rest of her family were at the SEAAK library, which is 2 blocks from there, where the Egan Center is now. And they were, of course, watching, came over, and this was what they saw. Plus, it was on fire. So when she got this family to bring her back, she tapped her family on the shoulder. They were greatly relieved that she was not in there. And one person died here from being crushed by a panel.
Precast panel came down. She was sitting in the car.
Actually, there was 2. There was her, and there was also a student from East who was killed here.
And that's the long wall on the backside. The other
Yeah.
side is the wall with the precast panels on it. So the eccentricity was extensive.
Which is why we do all this torsion and accidental torsion stuff.
Yeah,
That's cast in place concrete.
Yes.
that's cast in place. Yeah. I mean, the precast panel connections, of course, weren't designed to act as a shear element, and then they weren't designed to take anywhere near the movement that occurred.
Yeah, they were fairly thick precast concrete. They weren't GFRC. And my alma mater, West High School, you'll notice it does not have a second floor anymore. That's because they had all these cracks here at the second floor. So for the rest of that year and I think all of the next year, West double shifted at East High School. And then they moved back in here. They built the back end so that they could replace those classrooms. So the only part of the second floor that's still there is from about here over, which is the home ec, what used to be home ec rooms. I'm not sure what they use for it now. And then the choir and band rooms and the balcony access for the auditorium.
The auditorium was part of the original construction.
Yeah.
They're pretty low.
Yeah, up until the early 80s, that was where all the concerts were, other than the sports center. Here's the L Street.
Yeah, the L Street Apartments, I mean, basically it's Inlet Towers currently, but the damage you saw in both of these was pretty much the same, whether it was the McKay Building or the L Street Apartments. I mean, actually, when you look at it, the shear walls really aren't doing too bad. You know, there's some damage here at the base of this one. But what was fascinating was you see all these X cracks. It's the classic X crack link between shear wall elements. In other words, this guy was trying to make these guys work together and it couldn't, so it just spalled concrete like crazy.
Which is why we have all those requirements having diagonal bars through elements like this.
Yeah, tying together shear walls. Pretty much they packed new concrete into all the cracks in this building and put both of them back in. And the McKay Building actually has had a seismic upgrade. L Street Apartments has not.
Yeah, it's not called McKinley Towers.
Yeah, McKinley Towers.
Yeah, same diagonal cracks. See in both of these. And again, yeah, the shear wall seemed to be done just fine.
Yeah, I mean, it's got the exterior shear walls that have never been in. It's got concrete core as well around the stair and the elevators on the inside. The interesting thing about this slab is the slab is about that thick. So I forget what the span is on it. And then they put little, they recessed little wood strips so they could attach the ceiling directly to the bottom of the slab. And if you were ever in there before, it literally has creeped to the matter of inches on its span. It wasn't a little bit of creep, it was a lot of creep.
Yeah, I looked at it back in the late 80s for Mark Marlowe, who wanted to try to turn it into the city hall when they were trying to get out of their current building. And there was no way that those slabs could take 50 pounds a square foot, despite the fact that it had been a state office building for a while.
Mark Marlowe is the developer that did do the current rendition of it, including the seismic upgrade. Four Seasons apartment building, post-tension lift slab. It was lifted up in place and then it came down.
Yeah, they basically did not have enough of a lap at the base of the shear walls into the foundation. The rebar just stuck out just a little ways. So there's bond failure of that.
Yeah, and they were all unbonded post-tension flat slabs for the lift slabs on the building. And there were some that went zinging off to the north. Some of the houses you see over there actually had some, you know, pre-stress strand going through them. So it's gonna think of a giant rubber band.
Yeah, and it was within a few weeks of opening. It could have been a whole lot worse.
Yeah. For those that might have been here, this is still the old Providence Hospital. It was on the corner there at,
Yeah, this is looking down 9th Avenue towards the east.
yeah. So a little bit of summary of the November 2018 quake magnitude 7.1, strong ground motion, only about 30 to 45 seconds. I will freely admit it had me going because it was enough ground movement, you know, comparable in terms of ground motion to the quake in 64, but then it stopped after just a mere 30 seconds. So
Mere trifle.
yeah, but it's the one that's had me going the most since 64.
And again, it's one of those subduction kind of earthquakes where the North American plate and the Pacific plate are moving with each other. So, yeah, it was a whole different ballgame in 64, lasting 4.5 minutes. You know, even though it was not particularly intense, when you have it, you know, the magnitude is the area under the curve, right? So you have one that's a curve that's this long, but it's only this high. It's going to be intense, as opposed to like the 89 earthquake in Loma Prieta, it was only like 15 seconds long, but it was really intense. And that's how it became 7.
I mean, again, some of the same things, similar, peak ground motions. And a little higher in 2018 measured again. We're designing buildings a lot better now than we did back in 2018. I mean, it's one thing as a structural engineer. I mean, what's our best laboratory for seismic design? It's a major earthquake. And every time we go through a major earthquake, we learn better about how buildings behave.
Yeah, there was a lot of code changes due to 64, including the weight of snow on the building for one. The cross rebar and the link beams. What else? The torsional, looking at torsion in buildings. There's probably about 3 or 4 more others I'm not thinking off of the top of my head, but yeah, there was a number of changes.
And as I said, the Great Alaska Earthquake, it's something we've seen before and we will see again. And I mean, they've been able to dig into the ground and see the ground disturbance occurred in the past. And this is how that's how they figured out that this has happened in the.
Not maybe your great grandkids, but
Yeah. And when somebody says, well, I went through the quake in 64, well, we have not yet seen our design level earthquakes. I think you all know that. So. Is that our last slide?
I believe it is. Yeah. You can't get me at that number anymore.
No, I should have added retired here, but
Yeah.
anyway.
Yeah, if anybody wants to get a hold of me, my email address is akbosco, BOSCO @AOL.com. And my phone number is 907-248-2831.
That's our presentation.
So if we have another big earthquake like that, that same ground is gonna drop or in the same place?
It could.
Well, I mean, almost probably. Sounds like it. But having the same location every time.
I mean, yeah, the L Street Graben is that's not a one-time thing. It's occurred in the past. I mean, we'll get that ground movement again if we get that duration of earthquake.
Yeah, and there is, I guess, a level of disagreement between geotechnical engineers about the turning and slide. Well, you won't have it where it slid before because that's now compacted, but the stuff behind it might end up in it. So that's why in that area you have to do a very intense geotechnical report, even if you're doing a house.
Questions. That a very nice presentation. I like the personal experience part was really good. I tried to I've talked to a number of people. I was here, but I talked to several people that were, and I always get these stories that are really cool. But when you were talking about the 2% of G, that was kind of interesting. I've heard something like that before. Of course, that's way below modern
Right.
PGAs.
It's below what we're designing for.
Yeah, and some of the most recent stuff is off the charts almost if you look at some of the work they're doing now with USGS. But I guess what I was interested in is a lot of the design now is based on PGA and acceleration of gravity, but a lot of this damage is probably done due to the duration and the ground failure, which we don't really account for in the codes and designs. Is that true?
We do in Anchorage. I mean, that's why we have the ground failure hazard zones where you have to take a harder look at it. I mean, if we're designing buildings in hazard zone 5, you're going to get some kind of a recommendation from your geotech as to how much of this you're going to see is how much is this. And you have to account for that in your design. And the building safety is going to. They're going to want to see it, what the recommendation is from the geotech, and they're going to want to see how you address it.
I guess you kind of pointed to it. So 2% of G for 20 seconds is different than 2% of G for 5 minutes.
Yes.
And I don't think I haven't seen anything like that in the design standards.
I believe it's 20%, right? When it was,
Yeah.
it was 20%.
Yeah, 0.2, I meant to say.
Yeah. Yeah, and I don't know how you would, change your design to, are you designing for it to creep during the earthquake? No, we're not. They were trying to detail it so it's resilient, that they can go through the movement and come out the other end. And I think a lot of our current designs are doing that. They are much more ductile than
Yeah, the 2018 was a great demonstration, but it just made me think when you were talking, maybe our model doesn't count for that whole thing. Going on for 5 minutes is put you in a whole nother universe there, but
Right.
what that
Yeah.
means.
We design for strength and not energy.
Yeah,
Well,
Designed for ductility. in other
the
words.
ductility is
But-
basically a measure of your ability to absorb the energy. You know, they do all those graphs about it going back and forth.
Hysteresis.
The hysteresis curves. So yeah, that's built into the code, into the ductility part. So yes, we have the strength part, but then we also have all that ductility requirements that may end up with, much larger members than you have just from the loads. Because you've got a beam that's got to span this far. So you end up with a column that's much bigger than you probably need to be because you have to have a, weight beam strong column. And so it doesn't move as much.
And that's primarily a height limitation based on your seismic category is essentially any height,
Yeah.
it's baking in the heights that
Yeah.
must have a certain ductility,
Right.
right?
I've got 3 earthquake questions. One is, do you think 20% snow is enough
Yes.
in your seismic weight?
Yeah, because we're talking a 50-year snow and a 500-year earthquake occurring on the same day. And that's highly unlikely to happen.
Okay. And then, with the small projects I do, I'm always in equivalent lateral force. I think I've done one project my whole career. Well, I ever looked at dynamics, and so we end up designing a building based on strength, and it ends up being stiff. And these light wood structures are much stiffer now than diagonal sheathing, board sheathing walls. Are we gonna find a problem where we've been designing our buildings too stiff?
I don't think so, because I think for one thing, we have a lot more windows in houses now than we did before. So they have to be stronger and stiffer because you've got less shear wall. And if you look at all those houses, they had a few punched windows. Now we've got, some houses where it's practically a strip window.
Right.
You don't have much shear wall left. So it needs to be, sometimes you have to double sheet it just to get it to work because you don't have that much left. So yeah, they had so much more shear wall to work with back in those days. They didn't have hold downs.
But I mean, some of those houses might have board sheathing on the outside. It probably has some kind of a lath and plaster inside finish. If you go back all, so construction is very different then than what we currently do now.
And they probably had a lot more interior walls.
Yeah.
That had
Right.
double,
Smaller rooms.
plaster and lath or gypboard, both sides. So you got some stiffness from elements that you weren't relying on.
Then finally, about hysteresis curves. It's like every time an earthquake hits, it's gonna bend the nails in a shear wall a little bit and gonna take some of the life out of the building. How do we account for that? You don't know. Is this a concern?
after the capacity after the earthquake.
Yeah, and each successive earthquake, the hysteresis curve.
Go back and replace all the nails.
Yeah, take off all the siding, re-nail it, turn that stud into pieces of toothpicks.
It's like saying you're gonna get into the ductile behavior sooner, the more often you have an earthquake.
Yeah.
So you really want to make sure it's gonna behave ductily and not fall.
And we have more earthquakes than the rest of the United States combined, and we have 80% of those that are 5 and above. So I always tell people that if you're a structural engineer, Alaska is a perfect place to go because we have more earthquakes, we have hurricane force winds, and we have lots of snow. So if you like to do structural engineering, here's the place to come.
Trying to not to neglect our online folks. So Andrew had a question.
For specific buildings, okay, is that the first one?
That's the only question
Only
we've
question, right?
got, yeah.
Can't think of any that,
What did it say? I can't read.
Great talk. Is your experience, in your experience, is there any areas or specific buildings that have you worried for the next big one? I mean, first thing I'll say is that the 2018 is showing us that we're really designing buildings better because, you know, the damage we had 2018, and most of that really had to do with liquefaction issues and stuff like that, in areas where we weren't even building homes, you know, back in the day. And the buildings really behaved very well in general. I won't talk about Eagle River or the valley, but anyway,
That was mostly residential, but
Yeah.
not all.
it's no, I think, you know, in general, we're really doing a lot better in terms of how we're designing. And
Yeah, and I'm pretty sure that the three schools that had major problems, Colony, Houston Middle School, and Eagle River Elementary School were all designed by the same firm. She's not was not a local firm. But now they've all been upgraded, so it's not a problem. Well, if it's now Houston High, we had this discussion in Juneau. I designed Houston High School, which is across the parking lot, which is just fine, and they used it ever since until they're now opening Houston High School now across the street. So it was like, yeah, Houston High School failed. No, it didn't. Houston Middle School failed. It's just now Houston Middle School. No, it's Houston. Anyway,
I got a follow-up question. What about the inlet tower that you showed that didn't get those seismic upgrades that maybe the McKay building did, that had the X's that they just poured in some concrete into those cracks?
keep in mind, I mean, the main elements, the shear walls actually weren't that bad. The links between the shear walls had the classic failure.
and that's not gonna bring the building down.
No, I mean, if the building, it's gonna move more because there's not good links between the shear walls, but we really weren't seeing that much damage in the shear walls on the outside when you look at it.
And you didn't see any of that damage after the 2018 earthquake. Oh,
I mean, it's got a lot of concrete walls to it. It's just around the perimeter. They're just-
Yeah.
Think of them as tall shear walls with not so great links between. Does it meet the current criteria for seismic design? Not even close. But, you know, it didn't behave that badly in 64.
And I was remembering how skinny one of those shear walls was connecting to two kind of larger, nicer
Yeah.
looking ones in the links between.
Yeah.
Yeah, I'm sure that's not.
and you know, when I first got up here in 83, I designed at least 2 or 3 steel moment frame buildings. Way before the 94 quake that made us jump through hoops based on, you know, tall buildings that only had one, moment frame that were very heavy beams, very heavy columns that failed because it was a really thick weld. And every moment frame, no matter what it was, had to jump through hoops. And a lot of these were, you know, W18 by 35 beams, columns. They're very small. It's really hard to get a bad weld in it. And those buildings went through the 2018 earthquake just fine. There was no problem. Other than water damage, but they didn't know how to turn off the water. So it was going on for like 8 hours.
I got a question from Olivia.
Actually, the answer to that is yes.
What's the question?
No, the question is, for both of you, was it your experience surviving this earthquake that inspired you to become a structural engineer? Yeah, after that, I always had an interest in earthquakes, went off to college. First thing I did was declare double E because that's what my grandfather had been and my dad had been. Decided, no, earthquakes. And it was earthquakes all the way. And of course, going to school in California is a great place if you want to do earthquake design. So came back home and designed a lot of buildings for earthquakes. So yes, it had a very big part for me.
Interestingly enough, my first boss, Leslie Robertson, who designed the World Trade Centers, the original one, he started out as an EEE at Berkeley and then started designing towers for high voltage wires and ended up moving into structures from that and has done some amazing buildings coming off of that. I don't think he ever went and got a master's in it. He just did it by, learned by doing. But yeah, when I was a junior in high school, trying to figure out what college to go to, I figured I needed to know what I wanted to study. They also had to have a ski team, cross-country ski team. And so my dad was an architect, so I knew about engineering. And I thought about accountant and mathematician, but they both sounded pretty boring to me. So engineering, the civil engineers who did parking lots, water lines and sewer lines. That seemed kind of boring. Electrical engineer who did power and light. It's a good thing I didn't go to that because I was never very good at doing inverses and that kind of crap. Mechanical engineering who did ductwork and plumbing. And there were structural engineers who made the building stand up. So structural engineering is where I went. And of course, I got to my little technical school in Cambridge, and mechanical engineers were doing analog computers and these. Electrical engineers were designing computers, and civil engineers were doing parking lots and water lines and sewer lines. So I stuck with structural engineering, and I don't regret it. I had a good career at it. Worked on some really fun projects. Yeah, every time I see a movie or a TV show that takes place in Pittsburgh, I go, oh, I did that building. Hard to miss. 43-story Gothic glass towers.
Any more questions online
Or in here.
or in here?
Oh, thank you.
Thank you.